Welcome. The last video we went through the Fizeau experiment, and this was the worksheet that you were doing with me. We're now going to have a look at question two. Well, it's actually part B of this experiment. This worksheet. And this is actually a Fizeau experiment. This is where we're going to calculate the speed of light. So let's just read it together. In a separate experiment with 40 equally spaced teeth, in other words, once again, it's going to be 40 teeth and 40 gaps. The minimum rotational speed to block a light, light going through the cog wheel, the teeth and the gaps, is 2,400 radians per second. The distance between the light source and the mirror will be 5 kilometres, and we are going to determine the accuracy of the data collected in this experiment. So the data collected would have been the rotation of the cogwheel, because that's the thing that we actually measure when doing a Fizeau experiment. We just need to find the minimum velocity, the rotational velocity that blocks the returning light. Okay, so in doing that, let's calculate what we need to, the speed of light. So to calculate the speed of light, we need to calculate velocity being equal to distance over time. And we know the distance over time, distance here will be 5 kilometres. So that's the forward and the back. The forward would be 5 kilometres and back being 5. So it's 10 kilometres in this Fizeau experiment. So this is 10,000 metres. Divided by t, this is what we need to calculate. And this velocity will be the velocity of the speed of light. So if we can calculate t, the time taken for the time of flight from the actual mirror, so here's the cog over here, cog, and hitting the mirror and back, so the time taken for this entire journey there and back, then we can calculate the speed of light. Right, so the other information that we've given that omega is equal to 2,400 radians per second. And we know that omega is equal to theta over t. And theta is the minimum turn that is required for the blocking of the light. So we've got 40 teeth, that's 40 teeth, and 40 gaps. So that's 80 positions. And like I explained last time, if I've got 80 positions, then the wheel only needs to turn 1/80th of a circle to block the light. So theta would be 1/80th of a circle, which is 2 pi's angular displacement. So that's going to be 2 pi on 80 or pi on 40. Right. So using our formula again here, that time would equal, if omega is equal to theta on t, then time would be theta on omega. So that is pi on 40 divided by omega, which is 2,400 radians per second. Calculating that, we get, let's see, that's pi on 40 divided by 2,400, and I get a value of, let's put that up a bit, 3.2724, I'll just round that to 4 decimal place, 5 significant figures all up, and minus 5. Okay, seconds. Right here. Now, we've got that. We know what this one over here would give us. So our velocity of the speed of light would be 10,000 divided by this value over here, which is 3.2725 by 10 to the minus 5. And calculating that would be, it's 10,000 divided by the answer we previously got, which is 30557. I'll just write them all down. Okay, let's round this to the right number of significant figures. 1, 2, 3, 4, 5, 6, 7. So that's 30558 or 3.0558 by 10 to the power of 8 meters per second. Oops, that's gone off the screen there. I'll move it up for you. Okay, right. So that's what we've calculated as the speed of c for this experiment. Our question is, what is the accuracy? Excuse me. The accuracy, of course, would be how far this differs from the true value. We have noticed that the value is slightly higher, so therefore it's going to be over the 100%. So the easiest way to work here would be to work out the percentage error and then subtract that from 100. So working out the percentage error, the way that we know that we've got 3.0558 by 10 to the 8 minus the speed of light, which is the real value, and that would be I'll just do that. That's 5.57 ... by 10 to the power of 6, and divide that now. So this is percentage error would equal 5.57 by 10 to the power of 6 over the true value of c times 100. So doing that calculation, so dividing by 3 exponent 8 times 100. So it's a 1.86% error. Okay, so that's the percentage error. I can do percentage accuracy now by subtracting that value from 100. So it's 100 minus this answer. So it's 98. So 98.1. I'm losing accuracy, precision each time, so I'm rounding here now to 3 significant figures. Percent accurate. Okay, you can always go down in accuracy, in precision, you can't go up. So I've kept as many decimal places here as possible, and then I'm rounding basically to 3 at the end here. Okay, so this is that's B. Have a go now and see if you can reverse engineer for question C. Okay, thank you.